Okay, so we're going to take the derivative here. So the first thing we're going to do is rewrite. So we're going to rewrite this as a power. So square root means power of 1/2. So when we take the derivative here, we need to use the chain rule, the power rule, and the sum difference rule. So we bring the 1/2 out front. The input stays the same. We subtract 1 from the exponent, so we get negative 1/2. Then we have to multiply by the derivative of this input, which is 2x. So to simplify this, those 2's can cancel out. So we can have f prime of x is equal to x times x squared minus 7 to the negative 1/2. And if we wanted to rewrite that, probably see it written like this. So again, the rules we used here is we used chain rule, power rule, and sum difference rule. For question B, we have a product, but since this factor has a power of 2, we're going to use the chain rule as well. And because there are plus and minus signs, we're going to use sum difference. So this might be easiest to start it out and saying that y is f of x times g of x. F of x is x minus 3 squared. So f prime of x, 2 comes out front, subtract 1 from the exponent, multiply by the derivative of inside. In this case, this is just 1. And then do the same for g of x. G prime is 4. So now we're going to go to the product rule, which tells us we go f prime times g. So 2x minus 3 times g plus g prime times f. Don't forget this is x minus 3 squared. So now, if we want to simplify this a little bit, I suggest you factor out what's in common between these two terms. So these terms both have an x minus 3 in them. So we can factor out an x minus 3. That leaves us with a 2 of 4x plus 1 plus 4 times x minus 3. You could probably leave it like this, or you could expand it out. It's kind of up to you. Sorry, I missed a bracket here. So we should have a bracket here and bracket here for where we factor out the x minus 3. If we multiply out what's in here, we end up with x minus 3 times 6x minus 5 times 2. Question C. So there's a couple ways of doing both C and D. One way is to just rewrite this as a quotient that each have a power of 10. The other way is to do the chain rule and then use the quotient rule. So I'm going to do C one way and D the other way. So what I did for C is I started by using the chain rule, and then I used the quotient rule, and then like most questions I end up using the power rule and sum difference as well. So f prime of t, I take the 10 out front, leave the input the same, decrease the exponent by 1. But now I need to multiply by the derivative of the inside. For the derivative of the inside, I need to use the quotient rule. The quotient rule tells me I go f prime times g. So that's 2t times t plus 1, subtract g prime. The derivative of t plus 1 is 1, times f all over g squared. So I can simplify up here a little bit. This would be 2t squared plus 2t minus t squared minus 1. All over t plus 1 squared. So, and this in here equals t squared plus 2t minus 1 all over t plus 1 squared. You could leave it like this, or you could rearrange things a little bit. It's fine to leave it this way. Okay, for D, the other method that we could have also used for C is to rewrite this as a power of the top divided by a power of the bottom. And now we can use the quotient rule, and within the quotient rule we will use the chain rule. So the quotient rule tells me I take f prime. So f prime is the derivative of the top, which is 1/2 x squared minus 1 to the negative 1/2 times the derivative of what's inside, multiplied by g, subtract g prime, g prime times f. All over g squared. Okay, so to simplify these ones, we look for what's common, and we're going to factor out, you know that both these ones have a factor of x squared minus 1 and both have a factor of x squared plus 1, and we take out that factor to the lowest exponent. Also, you'll see that these 1/2s and these 2's cancel out, so it cleans it up a little bit. So I'm going to factor out x squared minus 1 to the negative 1/2 and x squared plus 1 to the negative 1/2, and that's going to leave me with x times x squared plus 1. When I divide out a negative 1/2, that exponent becomes 1, minus x squared minus 1 to the 1, all over, well, x squared plus 1 to the power of 1/2 squared is just x squared plus 1. So now I can simplify the top a little bit. I have these factors out front. And what's left in the brackets? Since both of these terms have an x, I should factor that x out as well. So we'll move that to the front. And all I have is x squared plus 1 minus x squared minus 1, which ends up being a value of 2. And this is all over x squared plus 1. So of course we usually write the 2 out front, so we can write this as 2x Now if you wanted, you could move those negative exponents so that they're at the bottom. So 2x over x squared plus 1 ends up being to the 3/2 once we combine it with what's already here, which is x squared plus 1 to the 1, and x squared minus 1 to the 1/2. Okay, last two. So here we need to use the chain rule twice for this one, as well as the power rule. So when we take the derivative of this, first thing we do is bring the 3 out front. Input stays the same, decrease the exponent by 1. Now we need to multiply by the derivative of sine of 2x, but the derivative of sine of 2x requires the chain rule again. The derivative of sine is cosine, so it's cos of 2x times by the derivative of the input, which is 2. The only way we can really simplify this is multiplying this 3 and the 2, so 6 sine squared of 2x times the cos of 2x. F, we need the quotient rule here. So f prime, take the derivative of the numerator, which is cos x, times the denominator, subtract the derivative of the denominator times the numerator, all over the denominator squared. Simplifying what's on top is cos squared x plus sine squared x all over cos squared x. You should remember from 30 pure, or from 30-1, sorry, or it's on the formula sheet, of course. Cos squared x plus sine squared x is 1. So the derivative is 1 over cos squared x, and if we're getting really fancy, we're going to write this as secant squared x. So most people did very well on this question, and it's good to realize, if my pen's going to work, good to realize that you actually just proved that the derivative of tan of x is secant squared x.